Ladies and gentlemen, good morning and welcome to MFTG. Today I would like to share with you some of the recent progress in meaningful type game theory. That's MFTG. The agenda now in the next couple of minutes is to describe you a class of games with empathy, means empathetic payoff, so that we can analyze the structure and the effect of empathy in the decision making of the agent. So here is the study. We consider a finite number of agents, and each of the agents has a certain action space, and the set of action space can be discrete or continuous, it doesn't matter at this step. And there is an empathy structure for each of the agents. So the empathy structure for simplicity could be, for example, a vector when you have n agent, finite number of agents, so n agent. And then for agent I, for example, the vector will be lambda ij, lambda ii, lambda ij, j different from I. So that will be a vector of if you collect all those vectors from all the agents, you get a matrix lambda. So given a pair function of meaningful type, means the pair function of agent I, for example, will be denoted by Ri, and Ri is a function of the action profile of all the agents, but also the distribution of the action profile of all the agents. Okay, so Ri maps to a real number so that you can do comparison. That's classical in game theory. And now given an empathy profile, which is now a matrix lambda, and a payoff profile that's a vector of functions that's R, we construct an empathetic preference, right? So in this particular case, we use just a scalarization technique. It maps lambda and R to the product lambda R, which will be a vector because a matrix times a vector, and then you get the vector functions, right? And that gives you the empathetic profile. So for example, for player I, the empathetic profile of lambda and R will be given by lambda I Ri plus lambda ij summation over j, lambda ij rj, right? So that will be the empathetic profile of agent I. Now the summation is over j in the neighborhood of I, and the neighborhood ni does not include the I, right? Now depending on the sign of those lambda, you get different cases, right? When lambda ij is positive, it means that I is altruistic toward j, partially altruistic toward j. And if lambda ji is positive, then j is partially altruistic toward I. Now, if lambda ij is positive and lambda ji negative, then I is helping j, but j actually is spiteful toward I, right? So there are multiple combinations. Of course, lambda ij could be 0. You might be neutral with respect to the pair function. Now, the same thing for lambda ii. So lambda ii could be 0. That's selfless. Lambda ii to be positive. That's partially selfish. And lambda ii to be negative. That's a self-abnegating agent I. So here are the results. And the first result is about consistency of the empathy structure. Now, we say that an empathy structure lambda means a matrix lambda to which we associate a graph. Actually, the graph connection of between all the agents, all the interacting, all the empathetic connections, right? So to lambda you associate a graph or network of connection between the agents, and this lambda is non-pathetically consistent if the equilibrium structure, the empathetic equilibrium, remain the same for any empathetic order k. Now, what is an empathetic order k? Well, for k equal to 1, it's lambda r. For equal to 2, lambda square r. For equal to 3, lambda 3r. So lambda is a matrix into the power k times r. Now, if for any k more than 1, if the empathetic equilibrium remain the same, we say that lambda is a consistent empathy profile. So here are the claims. The first result is that if you take the matrix with 1, 1, 1 everywhere, normalized by n, then you put a factor there, let's say rho, this gives you a consistent empathy profile. And if this rho is positive, now if rho is negative, this it's inconsistent, because you get minus 1 into the power k, k being an integer, so it changes the sign. So the equilibrium strategy, the equilibrium payoff from maximization goes to minimization, and so it changes radically depending on the payoff function r, of course. So when rho is negative, this is not consistent. When rho is positive, this is consistent. And this extends to more general case for any matrix lambda such that lambda k is equal to epsilon k times lambda, epsilon being positive, you get consistent empathy profile. And when epsilon k changes the sign, you get inconsistent empathy profile. And inconsistent empathy profile might go to self-negation, might go to spitefulness among the others. Okay, so this is the preliminary results that I would like to share with you today. I would like to thank you for your attention. Thanks for your time, and see you soon on MFTG. Bye.